Hi guys, let's review a little bit about triangles and the Pythagorean theorem. So first we're going to start with this triangle here. It's called a right triangle because it has at least one right angle. A right angle measures 90 degrees. And as long as a triangle has one 90-degree angle, it'll be called a right triangle. When you have a right triangle, the side directly across from the right triangle is called the hypotenuse. And the sides that connect to the right triangle or touch the right angle, the two sides that touch the right angle are called the legs. Generally speaking, when we have that right triangle, the hypotenuse, the one directly across from the right angle, we use the letter C to represent the hypotenuse. And the two legs are represented by A and B, and they are interchangeable. In other words, it doesn't matter which leg is A and which leg is B, as long as the legs are A and B and the hypotenuse is C. Whenever you have a right triangle, then we know the Pythagorean theorem always applies. So if you have a right triangle, Pythagorean theorem will work. If the Pythagorean theorem works on a triangle, then we know it is a right triangle. It goes backwards and forwards. Here's the actual formula. C squared equals A squared plus B squared. In other words, if you take the longest side and square it, it's going to equal the leg squared plus the leg squared. So that's a formula that we can use kind of like a plug and chug when we're trying to find one of the missing sides. So let's look at two examples. The first example we have here, we see that it's a right triangle because this little box here tells me it's a right triangle. Since it is a right triangle, I know Pythagorean theorem applies. When I look at it, the side directly across is the hypotenuse, or the C. In this one, they've labeled it X because remember, you can use any variable you want for a missing value. So this right here is the hypotenuse, and these two are the legs. So we have two of the three pieces of information. We can plug it in. Remember the plug and chug, where we plug it into the formula and solve for the missing piece of information. So I take the formula. I know that the 3 and the 4 are the legs because they touch the right angle, and the C is what I'm solving for. So the A, I'm just going to put in the 3, and the B, I'm going to put in the 4. I've plugged them in, and now I'm going to solve them. So let's use our order of operations. We do exponents first. Remember PEMDAS, we do PEMDAS. P is parentheses, E is exponents. So we're going to do the E. 3 squared is 9. 4 squared is 16. So we've done the exponents. Then we go through PEMDAS. The next thing we have to do is the addition. 9 plus 16 is 25. So we end up with C squared equals 25. Well, we don't want to know what C squared is. We want to know what actually C is. So the inverse operation, remember inverses undo each other. The inverse of squaring something is to take the square root. So a square root cancels a square. Square root is the opposite of squaring, and those cancel each other. But if we square root one side, that means we have to square root the other side. So we have to ask ourselves, what times itself gives you 25? And that answer is 5. So we know that our missing side up here is 5. So let's do one more example here. What is X? Here's our triangle. We know it's a right triangle because it has the symbol that tells us it has a 90-degree angle. There's 3 sides here. Since we know it's a right angle, we can use the Pythagorean theorem. We have 3 pieces of information here. Well, we have 2 of the 3 pieces of information, so we need to plug it in. First, we need to decide which one is the hypotenuse. There's the right angle. The one directly across is the hypotenuse. So the 13 represents the hypotenuse, which is the C. So that goes in for C. These are the legs, a 5 and an unknown. So remember, they're interchangeable. It doesn't matter where we put the 5. I'm going to put it in for A. And then B, we don't know what it is. B is what we're trying to solve for here, which is our unknown side. 13 squared is 169. 5 squared is 25. Now we want to solve for that B, so we need to get that B by itself. Well, right now this B is being squared, plus we're adding 25 to it. So we're going to reverse. Since we squared and then add 25, the opposite of adding 25 is subtracting 25. On this side, we end up with b squared because the 25's cancel. 169 minus 25 is 144. But we don't want b squared, we want just b, so the opposite of squaring is square rooting. Whatever you do to one side, you do to the other. The square root of 144 is 12, and we know our unknown side is 12. So that's the long and the short of it for Pythagorean theorem. It only works on right triangles, and if it's a right triangle, Pythagorean theorem will work. If Pythagorean theorem works on a triangle, then you've proven it's a right triangle.